This is welcome to the YourPedia. Me and Manish sir will start a full mock for the BARC. So welcome to the YourPedia. Please give your brief intro about yourself.
Yes, sir. Okay. Thank you, sir, for giving me the opportunity. So my name is Pratyush Sinha. I basically belong from Patna, Bihar. I did my schooling from Kendriya Vidyalaya School, CBSE. Then after I went to Bangalore for pursuing my B.Tech program. So I did my engineering from Bangalore Institute of Technology, and I'm a 2020 pass out candidate. After that, I appear in GATE exam, and through my GATE score, I got admission into NIT Patna. Recently, my MTech is completed in NIT Patna, like 1 week back only. And right now, I'm preparing for BARC exam. And my exam date is on 29th of May, this Monday.
Monday. Okay. So in which year you just pass out?
2020 pass out, and 1 week back only, my MTech also got completed.
Okay. So you have also completed your MTech. So what's your thesis title?
My thesis title is Design and Analysis of Double and Single-Ended Tuning for MEMS Gyroscope.
Double-handed and single-handed gyroscope?
Yes, sir, gyroscope. It is about MEMS gyroscope. We did some analysis and...
What actually you are doing that?
So in gyroscope, we have done a finite element simulation and tried to improve the efficiency of a gyroscope, all these things. We have done frequency study at different frequencies. What is the behavior of a gyroscope? All these things we have studied, and how to improve the sensitivity. That study we have done on the gyroscope.
Okay, can you just define what is the angle of precision?
Sorry, sir.
What is the angle of precision? Axis of precision and axis of spin.
Okay, sir. Sir, axis of precision, sir, actually I've not gone through theories of machine subject, but okay, I will try to recall. So axis of means like when in mechanical gyroscope there is a rotating spindle. Okay. So whenever it is subjected to any kind of rolling or something, the spindle does not change its axis because of conservation of angular momentum. So from that we used to predict that how much is the precision angle and all these things. So it all comes under mechanical type gyroscope.
What is the active couple or inactive couple?
Sorry, sir, I have not revised those things actually. I have not.
Beta, one thing you will notice about that when your thesis project is totally based on the gyroscope, so you are not know about the what is a gyroscope actually.
Yes,
so how can you justify the interviewer?
So that
either it is a design based, but first of all you are just know about the basics thing, na? What actually the gyroscope is it? What is the function of the gyroscope? If the vehicles will take a turn, let us take, I'm just assuming that there is one aeroplane which is having the rotor in the forward, in the front, and it just take the left turn. So how the gyroscope couple will act? You know?
Yes, sir. Yes, sir. That is like a thumb rule we apply. That if the rotation is in clockwise, then in which direction it is rolling motion is happening, in that direction it will rotate. In the opposite direction, then thumb movement, it will go in the upward direction. That is a way to determine if that is the direction of gyroscopic couple.
Okay, so one thing I will suggest you just thoroughly read the gyroscope. And what are the any application related to the gyroscope, you have to study it in a very good manner. And if you are interviewed 20 of 9, don't leave your MTech project. It's a really a very helpful. Most of the question will ask from the MTech.
Yes.
Okay. Today I'm not feeling so good that you are just prepared in a MTech. So I'm just going to switch the technical subjects. So what's your technical strength? Which subject you like the most?
I will just close the window. So just a second.
Okay, you can.
Yes. So my favorite subjects are strength of material, thermodynamics, heat transfer, and refrigeration and air conditioning.
Refrigeration and conditioning. Can you just tell me a brief intro about the refrigerant? What is actually refrigerant? How the forming of ice will be happen?
Sir, refrigerator is a device.
Refrigeration. So refrigerant. I'm talking about the refrigerant, not refrigerator.
Okay, refrigerant. Okay. Sir, refrigerant is a fluid which passes in the refrigeration cycle. So what is the main purpose of refrigerant is that the fluid goes through evaporator and condenser. It extracts latent heat from the conditioned space, and then rejects the heat to the ambient atmosphere. So that is the main role of the refrigerant basically. So there are classification of refrigerant like primary refrigerant, secondary.
Can you just tell me how the CFC will affected the ODP?
CFC will
affected the ODP, ozone depletion potential.
So the main element which actually adversely affect the ozone is chlorine basically. So whenever we have a refrigerant and it has a chlorine in its formula, means it is going to harshly affect the environment, the ozone layer. So that kind of refrigerant we should use, which is chlorine free. So for example, R134A, that is chlorine free.
How chlorine will affect the ODP?
So it is said that means like chlorine has an adverse effect on surrounding. It is not an eco-friendly thing.
How? Kaise?
Sorry, sir, I don't know.
So what's the general refrigerant?
Right now, most commonly used refrigerant is R134A, which is used in domestic fridges, and that is basically eco-friendly. Recently, it has been developed in laboratory.
अच्छा, जैसे ये जो हमारे CFC हैं, हमारे जितने भी रेफ्रिजरेंट, इससे पहले हम कौन सा रेफ्रिजरेंट यूज करते थे सबसे मोस्ट कॉमनली?
सर R12 was famous. R12 was
CFC से पहले कह रहा हूँ मैं. I am talking about before the CFC refrigerants.
CFC से भी पहले सर actually apart from CFC we can also use ammonia and drying solution.
सबसे पहले हम लोग ammonia यूज करते थे, है ना? One thing you noted. Why we just reduce, मतलब we just exclude the use of the ammonia when it is easily available. सब कुछ हम आराम से यूज कर सकते हैं. क्यों छोड़ दिया हमने यूज करना रेफ्रिजरेंट में? It is also not affected the ODP. It is a zero ODP, है ना? So then why we are not using the ammonia as a refrigerant now?
So even right now also ammonia is used in some mega industries, like very large size industry. Sometimes we use ammonia, but most commonly in our household we don't use ammonia because ammonia latent heat of vaporization is good, but the thing is the gas is quite toxic and it has a very high pungent smell. If in case if it starts leaking, then very pungent smell will start coming out of it. So it is harmful for us to inhale. But in large size industry, mega industries, people are using ammonia VARS system for refrigeration. Ammonia they are using in some industries.
Okay. Can you just tell me? Can you just draw the adiabatic saturation on a psychometric curve?
Okay. Shall I draw it?
Yeah, you will draw.
This is adiabatic.
Which properties remains constant? Which property change?
So dBT is 1 second. Okay, dBT is changing. It is cooling with humidification, and enthalpy remains constant, and wet bulb temperature also remains constant.
What about enthalpy?
Enthalpy, sir, it remains same actually. It's
why? Why in the case of adiabatic saturation enthalpy is same?
Sir, because temperature decreases, so we know that by decrease of temperature, enthalpy should be decreasing. But when the temperature is decreasing, but more water vapor is also adding to the atmosphere, isn't it? So mass of vapor is increasing, so that's why enthalpy remains the same. I will write the equation and show you how it is the same. Just
okay, just write the equation.
So this is the formula. Okay. So when temperature decreases, enthalpy decreases. When specific humidity increases, so we know that mass of vapor also increases. So because of that, enthalpy, because W is increasing, so this will increase. Temperature decrease, this will decrease. So both will compensate, and the enthalpy will remain same.
Okay. Can you just tell me when we just use the AC air conditioning, which properties are balanced by or given by the air conditioning, maintained by?
Sorry, sir, I'm not getting your question.
When we just use the air conditioning, so which properties are maintained by the air conditioning, है ना?
Okay, sir.
क्या maintain
So,
करता है air conditioning?
okay. So air conditioning is used mainly for human comfort. Whatever the parameter which makes us human beings comfortable, that we used to control. So in air conditioning, we can control temperature, then humidity, purity of air, and the velocity of air. So as a human being, majority of the people is not.
What type of humidity? कौन सी humidity control करता है ये?
So relative humidity is the main factor which affects the comfort.
Why not specific humidity?
So specific humidity also get affected by it. Both gets affected actually.
कैसे? तो किसको कंट्रोल कर रहा है? स्पेसिफिक ह्यूमिडिटी को या रिलेटिव ह्यूमिडिटी को?
सर ऐसा करने पे हमारा दोनों चीजों में एक्चुअली चेंजेस आ रहा है. अगर मान लीजिए कि बाहर का टेम्परेचर है कि वो बहुत ज्यादा ह्यूमिडिटी अगर बहुत ज्यादा.
आपने एक चीज देखी, जैसे कि हम लोग कभी भी बताते हैं रिलेटिव ह्यूमिडिटी बताते हैं, बट वी आर नॉट गिवन अबाउट द स्पेसिफिक ह्यूमिडिटी. व्हाई? आप देखते होगे जैसे अपना AQI लगा रहता है, कहीं भी कोस्टल एरियाज पे भी हमारा जो इंडिकेटर लगा रहता है, वी ऑलवेज गिविंग द रिलेटिव ह्यूमिडिटी, वी नॉट मेजर द स्पेसिफिक ह्यूमिडिटी. एनी रीजन?
Sir, most of the human beings are comfortable in around 40 to 60% relative humidity. तो कंफर्ट जोन जो है वो रिलेटिव ह्यूमिडिटी से डिपेंड करता है, स्पेसिफिक ह्यूमिडिटी से नहीं. रिलेटिव ह्यूमिडिटी
क्यों नहीं करता?
सॉरी सर,
क्यों नहीं करता
सर? क्योंकि सर अगर हम
डिफरेंस क्या दोनों ह्यूमिडिटी में?
सर
there is a difference between the relative humidity and specific humidity.
So specific humidity is defined as the amount of vapor present in the air per unit mass of dry air. So it is gram of vapor divided by gram of dry air. That is the specific humidity. And relative humidity is defined as the mass of water vapor present in the atmosphere divided by mass of water vapor at saturation state. So that is called relative humidity. अगर हमारा ह्यूमिडिटी अगर बढ़ गया है, लेकिन साथ ही साथ अगर टेम्परेचर भी बढ़ गया ना, तो भी हम उसमें कंफर्टेबल रहेंगे, क्योंकि रिलेटिव ह्यूमिडिटी मेंटेन हो जाएगा. टेम्परेचर बढ़ाने से रिलेटिव ह्यूमिडिटी कम हो जाता है. तो मेनली हमारा रिलेटिव ह्यूमिडिटी ही हमारा कंफर्ट जोन डिसाइड करता है. अगर 40 to 60% इसमें RH है, तो हम कंफर्टेबल रह सकते हैं इसमें.
I didn't know about the grand sensible heat factor, GSH.
Yes sir. Grand sensible heat factor. First of all, sensible heat factor is sensible heat divided by sensible heat plus latent heat, total heat. So grand sensible heat factor means total specific heat divided by total specific heat plus total latent heat. Now what is total specific heat? Total specific heat is room specific heat plus outside surrounding specific heat. So both we add and it will become.
Can you draw the psychometric chart?
Yes sir. So this is it.
Okay,
So
good,
you are
good. Now, Pratyush, I will just give you the feedback. Overall, you are a good. You have a good knowledge of the subject. And a little bit reference थोड़ा सा आपका weak portion लगा मुझे कि जहाँ थोड़ा सा आपको ODP के बारे में और चीजों के बारे में थोड़ा सा और पता होना चाहिए, क्योंकि जनरली ये चीज क्या प्रैक्टिकल रिलेटेड है कि पहले हमारा एमोनिया आया, पहले हम लोग बर्फ से वो मतलब उस तरीके से कर देते थे, बहुत बड़े बड़े रेफ्रिजरेटर लगा देते थे, फिर एमोनिया यूज करना स्टार्ट किया, फिर सीएफसी का इन्वेंशन हुआ, सीएफसी के बाद भी हमारी प्रॉब्लम आने लग गई, फिर हमने मतलब सोसाइटी के थ्रू पता चला कि हमारा ये ओडीपी हो रहा है, फिर इसको रिमूव करना स्टार्ट किया। थोड़ी सी कहानी है, इसको थोड़ा देख लेना है ना, बाकी ठीक है। ओके
yes.
ओके, थैंक यू प्रत्युष। नाउ द अनदर फैकल्टी विल इंटरेक्ट विद यू।
Please,
ओवर
sir.
टू यू।
Thank you, sir.
Okay, Pratyush.
Good afternoon.
So, good afternoon. So, what are your favorite subjects?
So strength of material, thermodynamics, heat transfer, and refrigeration and air conditioning.
Okay. Okay. Strength of material, thermodynamics, heat transfer, and refrigeration. Correct?
Yes, sir.
Okay. So, now I'm going to start with thermodynamics, correct?
Okay, sir.
So, first of all, tell me what is thermodynamics and how it is different from heat transfer.
Okay, sir. So thermodynamics is a branch of science that deals with heat and work interaction and its effect on the properties of system and surroundings. So thermodynamics basically derived from two words, thermo and dynamics. Thermo means energy. Energy could be stored form of energy or it could be in transit form. And dynamics means transformation. Okay, transformation of one form of energy to another form of energy, transformation of heat to work, work to heat. All these things we are going to study and how it is going to affect the system and surrounding property that we are going to study in thermodynamics. Now, heat transfer is basically study of transfer of heat energy from one place to another place, which occurs because of temperature difference. So main difference is thermodynamics means energy transformation. So here heat is one form of energy and heat transfer is not transformation of one form to another form. It is only getting transferred from one place to another place. That is the difference. One more difference is thermodynamic only tells about the equilibrium points, that what is the final state of this. But in heat transfer, it also tells about the transient phenomena in between what is happening, how it is happening, that also it tells about. So temperature profile, all this is we are going to study in heat transfer, and how to utilize energy that we study in thermodynamics.
Okay, so what do you mean by internal energy?
So internal energy is basically it's basically the molecular energy of a thermodynamic matter. So suppose there is a thermodynamic system, okay, and then definitely it will have some molecular energy, right? Some in the form of kinetic energy, potential energy, some molecular energy is there. So that considering we call it as a internal energy of the system, energy which is possessed by the at the molecule due to molecules in the matter.
So what type actually energy they possess, molecules can possess? Suppose you have a matter which is having so many number of particles, correct, molecules. Then how you can say how much energy is stored in this particular material?
Sir, actually, in molecular form, when we talk about molecular form of energy, we have kinetic energy, potential energy. But for ideal gas, we ignore potential energy because potential energy because of intermolecular distance, and because of that potential energy is created. But in ideal gas, anyways, we consider that the distance between molecules is very large, so potential energy neglected in ideal gas.
Okay,
So
suppose you have 1 kg of coal.
1 kg of
coal.
Achha, koila. Okay.
Yes. So how much you have internal energy?
Sir, if we burn the coal, okay, if we provide combustion to the coal, then we can say that mc dt will be the internal energy.
So this is internal energy or this is a heat energy?
No, so this is the heat energy. Sorry. This is heat energy of the system.
So how you define internal energy for this substance?
So just a second, sir. So actually internal energy is mCV/dt. Okay, so specific heat at constant volume mCV/dt, we use that formula.
So here you get a constant volume process.
No, actually in solid mostly Cp and Cv are the same value actually. Cp and Cv doesn't have a different value.
Okay, so how you calculate internal energy?
Sorry, sir, I'm not sure about it, but in enthalpy will be definitely mCdt will be.
Okay, tell me first law of thermodynamics for process.
For a process.
Yes.
Okay, sir.
Burning
So
of coal is a process, or yes or no?
Yes, sir. Yes.
So can we apply first law of thermodynamics for process for this substance?
Yes, sir.
So apply and then tell how you determine internal energy.
So what I'm getting, because anyway work done is 0, so I'm getting change in heat energy is equal to change in internal energy. So that will be mc dt on this side actually I'm getting.
Okay, means after burning, the amount of heat generated is considered as a total energy, internal energy of the system, correct?
Yes, sir.
Okay. Can you define second law of thermodynamics?
Okay, sir. So the second law of thermodynamics is basically a qualitative law, so which tells about the feasibility of a process, whether the process will occur or not. If the process is possible or not, that it basically tells about that. So from second law of thermodynamics, there is a concept of entropy, with the help of which we can tell whether the process is feasible or not. So there are basically two statements in second law of thermodynamics. One is Kelvin-Planck statement and another is Clausius statement. Kelvin-Planck statement says that it is impossible to construct a heat engine which works on a cycle and it has heat interaction with only one thermal reservoir and it is continuously producing work. So this is impossible. And Clausius statement says that it is impossible to construct a heat pump which works on a cycle. It extracts heat from low temperature region and reject heat to the high temperature region without absorbing any work. So that is also impossible. These are the two statements.
Okay, let us say, suppose you have a process, correct?
Okay.
So how you identify whether this process is possible or not?
Sir, we are going to calculate the we are going to calculate entropy generation. Okay, entropy generation is change in entropy of system plus change in entropy of surrounding. So if the entropy total entropy generation, if it is positive, then it is an irreversible process. If it is equal to 0, then it's a reversible process. And if entropy generation is less than 0, then it's impossible process.
Impossible process.
Yes.
So total entropy or entropy for a system?
Total entropy. Entropy of universe. Entropy generation means system plus surrounding. If it is negative, then it's impossible.
Okay. And how you find quality?
Quality of energy.
Yes.
Sir, we say that heat is a low grade energy, low quality energy, and work we consider as high quality energy. Why we say low and high? Because work is said to be high quality energy because work can completely be converted into heat. So that's why we say high grade energy. But heat cannot be completely converted into work. So we say it's low grade energy because it cannot be completely converted into.
But I'm asking how you find whether how you find the quality of your energy available.
Okay, how to find the
Quality of
how much is the
available energy.
availability?
How you find the quality of whatever जो भी energy आपके पास है उसकी quality कैसे पता करोगे?
कि हमारे पास कितना availability है नहीं.
I'm not asking quality. You just think कि किस term में उसको answer करना चाहिए?
Sorry sir, मैं समझ नहीं पा रहा क्वेश्चन. लो ग्रेड एनर्जी, हाई ग्रेड एनर्जी.
एनर्जी की क्वालिटी को कैसे एक्सप्लेन करोगे, कैसे डिफाइन करोगे?
ऐसा ना कि लो ग्रेड एनर्जी क्या है और हाई ग्रेड एनर्जी क्या है, ये मतलब है.
If you have energy at high temperature, correct?
अच्छा, हाँ.
If you have energy at high temperature, then the entropy will be lower, correct? And if you have same energy at low temperature, then entropy will be higher. And if entropy is higher, then the quality of your energy is low. And if entropy of your energy is low, then it will be a better quality energy, correct?
Yes sir, yes.
Okay, Pratyush, so now I'm giving you your feedback, correct? So overall, you are good in thermodynamics also, correct? बस थोड़ा सा कई बार आप सोच नहीं पाते हो ना, तो एकदम गिव अप नहीं करना है. जस्ट टेक अ पॉज एंड थिंक अबाउट दिस, करेक्ट? थोड़ा सोचो एंड देन गिव आंसर. डेफिनेटली आपको आंसर मिल जाएगा, ठीक है?
सर जो आपने कोल का जो एग्जांपल दिया था, मैं आंसर सही दिया था उसका?
हाँ, करेक्ट है.
अच्छा, एमसीडीटी ही होगा
वो. अब आपको बहुत हिंट देना पड़ा इसके आंसर के लिए, है ना? जब भी ऐसा हो तो इमीडिएटली प्रोसेस के लिए थर्मोडायनामिक्स फर्स्ट लॉ अप्लाई कर दो, तुरंत पता चल जाएगा क्या होने वाला है. whether you have work done or not, if it is zero then internal energy is equal to heat. और हीट क्या होता है? बर्न करने से जो हीट जनरेट होगी, कैसे कैलकुलेट करोगे? एमसीपी डेल्टा टी नहीं लगाना वहां पे, डायरेक्टली आप कह सकते हो मास इनटू कैलोरीफिक वैल्यू ऑफ दैट फ्यूल. एंड एवरी सब्सटेंस हैज सम देयर कैलोरीफिक वैल्यू, करेक्ट है? एमसीबी से भी तो हम निकाल सकते हैं ना, करेक्ट? सो ओके प्रत्युष, ऑल द बेस्ट.